Background of people are making noise. Do you drink those days?
Sir.
So can you see the screen?
Yes.
Okay. Today we're going to do what we call the probability introduction. Our lesson, it won't be that much long because we're just doing what we call a small introduction about what we call the probability. So we're going to do a small introduction about what we call the probability. So if we check then our probability, about the probability. So some of you back then, you have learned that a sample space consists of all the possible outcomes for an event to occur. For an example, if a fair dice is thrown, the possible outcomes are obtained a 1 through to 6, because a dice have got what we call 6 numbers. So when we are talking about the what, the dice, so the sample space of a dice, we know that the sample space of a dice is 6. We've got 1 until 6. So again, you guys, you have learned that the probability, you have learned that the probability for an event to occur, the probability of an event is nothing but equals to what? The number of an event, or divided by the what? The number of sample space. This what you have learned back then. So now, as far as we are concerned, in general, E is the total number of ways a specific event can occur, and S is the total number of possible outcome for an event to do what? To occur. So when we're talking about what we call the probability, uh, they can say that if we are representing, let's say as an example, if we are saying P at A, this simple means that the probability, it simple means what? The probability of event A occurring. This simple means that the probability of event A occurring. If they say that if you meet something like this P, this means that the probability of event A not occurring. The probability of event A not occurring. So this is also known as what? This is also called the complementary of A. The complement of A. This also means the complement of A. When we're talking about P of A or B, this is the same, they can say P of A or B is one and the same thing. Are we still together? So this means that the probability of A or B occurring probability of A or B occurring. This one is the symbol for OR. It is also known as union. That's the symbol of OR. It is also known as union. Let's say the same probability of A and B. This is equals to probability of A and B. Here they want the probability of A and B occurring. This symbol is the symbol for AND. It's the symbol for AND. It is also known as intersection. It is also known as intersection. And if we're saying this one is either, this one normally you learn it at the varsity. This is the probability of A occurring given that B has occurred. This is the probability of A occurring given that B has occurred. Now we still together. Hello?
Yes.
Yes.
So now, you must know those language. So now, as far as we are concerned, when they talk about OR and they talk about AND, so let's say as an example, we're talking about probability of A or B. So here we're talking about if we go something like this. If we've got A or B, so it means we are going to take all the things that are in the cycle of A and that are in the cycle of what? Of B. This is what OR means. Are we fine? Hello?
Yes.
Yes.
If we're saying P of A and B, so this means if we've got something like this, let's say we've got our A and we've got our B. We're going to take everything that is in the cycle of A and B. That's what AND means. Are we fine?
Yes.
Then if we've got what we call A complement, if we have got cycle like this, let's say we've got A and we've got B. So when we're talking about A complement, it means we're going to take everything that is outside the cycle of A. Everything we're going to take here, as long as those things doesn't belong to the cycle of A. Are we good?
Yes.
Yes.
So if we have, let's say, P of A or B complement, so if we've got a cycle like this, if we've got a cycle like this, and our A and our B. So if they're saying not A or not B, it simply means that they need everything that doesn't belong to the cycle of A and that doesn't even belong to the cycle of B. Do you understand?
Yes.
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 So now, as far as we're concerned, we're going to say can we go to the next slide?
Yes.
Yes. No.
I heard yes, no. The person who said no, when you are done, please inform us on time so that we can proceed. Sorry? Was the person who said no still writing?
We can proceed.
Okay. So now, Let's go to the next slide. So now let's talk about what we call mutually exclusive. Let's talk about what we call the mutually exclusive. Mutually exclusive. So this is the main terms that are there in probability. When we are talking about something that are mutually exclusive, we can say that if two events are mutually exclusive, it means that they cannot occur at the same time or at the same trial. They cannot occur in the same trial. That's what we mean the mutually exclusive. Two events are mutually exclusive if they cannot occur the same trial. Are we still together?
Yes.
So now, as far as we're concerned, if we're saying those two events cannot occur at the same trial, it simply means that those events are what? Are mutually exclusive. Are we fine?
Yes.
Yes.
So now, like as an example, if a trial is tossing a dice and event A is obtaining a 6, while event B is obtaining 2, it is impossible to obtain event A and B together. Is that so? A dice can't fall by 2 and the 6 at the same time. Is that so?
Yes.
Yes.
So, uh, let's say if you are picking a cards on the cards desk, someone says I'm picking a queen, and event P says he's picking a spade or a heart. It's possible that you get a jack or a queen with a spade. Is that so?
Yes.
So for mutually exclusive events, it simply means that probability of A and B is equals to 0. That's what we mean mutually exclusive. The intersection is what? Is 0. There's no intersection. Can we proceed?
Yes.
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 So now let's talk about the addition rule. This is the formula for probability. Probability of A or B is equals to probability of A plus the probability of B minus the intersection. Are we good? So, but if two events are mutually exclusive, if two, or let's say if events A and B if events A and B are mutually exclusive, then we mean what? By mutually exclusive, we mean probability of A and B is equals to what? 0. Are we good? So now, therefore, it means our additional rule formula for probability of A or B is nothing but going to be equals to probability of A plus probability of B. Why? Because the two events are what? Are mutually exclusive. It's minus 0. Are we satisfied?
Yes.
Can we go to the next slide?
Yes.
Now, let's talk about the complementary event. Those are the words that we're going to use. Complementary events. So, if two events are complementary, if two events are complementary, if two events are complementary, we mean P of A complement. Are we good? Which is the same as we're talking about the probability of not A happen. This thing is equals to 1 minus the probability of A happening. It means we'll be left with the probability of not A happening. Are we good?
Yes.
So there
Yes.
are two conditions. There are two conditions that have to be there are two conditions that have to be true for events to be complementary. There are two conditions that have to be true for events to be complementary. Number one, the events have to be mutually exclusive. Are we good? Number two, probability of A plus probability of B must be equals to 1. Are we still together?
Yes.
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 So can we do examples and see if you guys or you are really following?
Yes.
Oh, before we go to example, let's talk about what we call the independent events. The independent events. Some they say this is the product rule, but we are talking about the what? The independent events. So if we're saying the events are independent, it simply means that the probability of A and B is equals to probability of A multiplied by probability of B. Are we good?
Yes.
And don't forget that probability of A and B can be written as this. So this is the same as probability of A multiplied by what? Probability of B.
Mm.
That's what we call the what? The independent
And then
events. Do we have any question before we touch a little bit of example?
now.
Okay. So now let's take an example. Let's say, or they say, if a fair die, if a fair dice is rolled, what is the probability of getting a multiple of 3? There we go. Here is your question. If a die is rolled, what is the probability of getting a multiple of 3? You can see the question right here. I hope you are writing.
Yes, we are working.
Yes.
Okay. Today we want to do many things. Now we don't want to confuse you. I will start together.
Yes.
We have to do things step by step. You're done, is that so? Hello? Guys, don't be quiet or don't ignore when we're asking you a question. Are you done? We need only yes or no. You must not act like Are you done?
Yes.
Okay, what did you write, if I may ask?
I wrote 2/6.
You said what in mathematics we work. Do you know that, right?
No?
You said in mathematics we work. Remember the sample space of a die is 1, 2, 3, 4, 5, 6. Is that so?
Yes.
So they need 3 and what?
6.
So he said that we get 3 or what?
Or 6.
This is the probability of getting 3 plus probability of getting 6 minus probability of getting 3 and what? Then to get 3 is 1 over 6 plus 1 over 6 minus what? 0, because we can't get 3 and 6. That's a what we call a mutually exclusive.
Exclusive.
We are still together, right?
Yes.
Yes,
So now, what do we do?
we add the numerator.
We add the numerator since the denominator are the same. That's so good. Is that so?
Yes,
Yes.
So, is it difficult? What did you get?
2 over
1
6.
3.
2 over 6, which is nothing but 1 over 3, which is what? 0.33, is that so?
Yes.
Yes.
So the probability must be always between 0 and 1. Are we good?
Yes.
Yes,
The probability must be always between what?
0
0
and 1.
0
and 1.
and 1.
Where 0 is uncertain and where 1 is a possible things to happen. Can we proceed?
Yes,
Yes.
number which is
Mm-hmm.
slash band sama
Mene?
kamba uji sangat band.
You're in grade 12. You can ask in English. We mix you here
I
with
wish
grade 11 students, learners. What do you want to teach them?
okay, I wanna ask Ben. Are we supposed to always write our answers in decimal form, or we can leave it in fraction?
It depends. Some they can allow you to write in fraction, but I think you can write it in decimal. But some you can leave it in fraction. There's no. It depends on which question are you working on.
Okay. But then if the other probabilities are given in fraction, which means my final answer must be in fraction.
Yeah.
Okay. Thank you.
You get you get the same marks if you leave it in fraction. I said if you leave it. So let's work it out. I hope you are working through it.
Yes.
Okay, that's nice. One minute left. Are you done?
No.
Okay, let's finish up. Portia, are we winning?
Yes.
Orgao, are we winning?
Yeah.
Fariso, are we winning? Fariso, please unlock your mic and reply.
Do what person supposed to say?
Why are you not asking? By the mathematical rule, all of you must be done, unless if you're not answering what I have asked. You can loop your mic, Fariso. If you don't understand, please, you must unloop your mic and ask the question, because you can't just stay like that without understanding. It's wrong and it's a sin. So guys, they said determine whether event A and B are mutually exclusive. Faris, so you can loop your mic. Whether event A and B are independent or not. So ourselves, we are given what we are given. It can be found on the formula. We have got probability of A or B. We know the formula of addition. If we see OR is equals to probability of A plus probability of
Plus
B
probability
minus probability of A and B.
and B.
So for event to be independent, we know that in order for us to say our event are independent, this rule must apply. Are we good?
Yes.
Yes.
But we can't tell because we don't know the probability of A and B. So that's why here on the formula we're going to substitute so that we can make our probability of A and B subject to the formula. Then this is equals to 0.12 plus 0.35 minus probability of A and B. Are we fine?
Yes.
Then, without skipping anything, this is 0.428 is equals to 0.47. Is that so? Hello?
Yes. Yes.
Minus
Yes.
probability of A and B. So we have to solve for probability of A. It means we're going to have 0.428 minus 0.47 is equals to minus probability of what? Of A and B. Are we fine? Then when you subtract,
Yes.
you're going to get what? Negative 0.042
Two.
is equals to
Two.
negative probability of A and B.
B.
Then when you divide both sides by that negative one both sides so that we eliminate our negative, we then get what? We then get that probability of A
of
and
and
B
B
is equals to
0.042.
0.042. Is that so?
Yes.
So now,
Yes.
remember, those people, they said let's prove that is a independent. So we must find probability of A times probability of B now. So this is equals to when we substitute, this is 0.12 multiplied by
0.35.
0.35. And what do you get?
0.042.
0.042.
So is this thing equals to this?
Yes.
Then you must tell them that therefore probability of A and B is equals to probability of A multiplied by what? Probability of B. And this only applies when what? They are independent. Is that so? That's why you are going to say thus A and B are what?
Are independent.
Are independent events. Any question?
No question.
Fariso, now Ozufesa, do you understand?
Yes.
Okay. So now let's proceed to the next one and see how are things. Listen now, the question says, yes, a question. Is it visible?
Yes.
Yes.
Okay. You can try that. Your time start and begins right about Njigamanje. Guys, I'm waiting for you. Ne?
We are done. I am done. Sorry.
Yeah, we always fight with your English.
Sorry.
What about others? Are you also done? Hello. Guys, don't act like Momo. You have got mics, right?
Yes, we're done.
Okay. The others who didn't confirm, others, let's confirm.
Yes.
Yes.
Oh, you're still busy. Is this thing difficult? Let's hear what you have written or go. Or go mkwebo. Mwanangu ruga. Utohumula so. Aina ninguruga. Aru, what did you write?
I'm not sure, no, but I used that formula which says P probability of A or B equals to probability of A plus probability of B minus probability of A and B to find A and B.
Minus probability of A and B. Then what do you do after that?
I substituted and said 0,8 equals
0,8. When you are given those kind of formulas, just go and write the given things and substitute. Is that so? Then
Yes.
0.3 minus probability of A and what?
Yes.
Then this is 0,8 is equals to 0. Minus probability of A and B. We can take probability of A and B this side because it's negative. Is that so?
Yes.
Yes.
And we take 0,8 to that side and it changes the sign to avoid many division.
Yes.
Then we get 0,
1.
then after this you must say is not equals to what?
It's
Is
not
that so?
equals to 0.
Yeah, because mutual exclusive
Yes.
when the
Yes.
intersection is equals to 0, you can
0.
write therefore A and B are not what?
Mutually exclusive.
Are not mutually exclusive. Are we fine?
Yes.
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 So now, can we proceed?
Yes.
Yes.
I won't add anything today. I don't want to confuse you. We must work through the same questions. Yes, a question? Is visible, is that so?
Yes.
Kaneka divayopita zezvili.
Eh?
Oh, ndakori kane icho yabvisa zvezvila zvino isharp.
Okay. Ebenezer we. Ebenezer. May you please look your mic. Hello. Ready? Look your mic. Let's answer this question, guys. How far? Are we winning?
Yes.
Okay. Portia, what is the solution of the first one?
Probability of A or B is equals to probability of A plus probability of B minus probability of A and B.
Mm-hmm.
Then the probability of A or B ravel 0.48 is equals to
Mm-hmm.
0.35 plus 0.2.
Mm-hmm.
Then rari 0.48 is equals to 0.55.
5.
A.
Mm-hmm.
Right, so 0,55 ingaki.
Oh, you ended up dividing by negative, ne?
Yes.
Okay.
Then probability of A and B is equals to 0,07.
Therefore, we get that
Therefore,
probability of A and
probability
B.
of A and B 0,07.
or 0,07.
Yes.
Okay.
Then therefore A and B are not mutual exclusive.
Yeah, they are not. Did you read the equation?
Yeah.
Hey. So, guys, did we all get the probability of A and B?
Yes.
Yes.
Right,
Yes.
9.1.2.
Yeah, and they were.
Ivo, who asked you that?
When you get 9.1.2.
We need the solution, guys. Please use the valid language that others, when they attend, we have got other students, other learners who don't even understand your home language. So we want them to be catered also, because this recording is going to be shared to them. I mixed grade 11 and grade 12 here because you do same thing, you guys, on probability. And those who are doing 11 next year, don't expect me to do this. You know this thing. We're going to straight to grade 12. Don't throw away your books. So, Rere,
No. Because the probability of A and B.
wait, Lily. You're too fast. You're on 9.1.2, right?
Yes.
9.1.2. You must answer it like a mathematics way.
Events A and B are not mutually exclusive because probability of A and B is not equal to 0.
Did you all understand?
Yes.
In mathematical ways, they said event A and B mutual is already, we have already got that indeed probability of A and B equals to 0.707 is that's not a mutually exclusive. So ourselves we're going to say what? No. Why? Because probability of A and B is equals to 0.07, which is not equals to what? That's how you answer in mathematical way. Are we fine?
Yes.
Yes.
Okay, let's proceed to the next question. I recall again, Portia, welcome back. You're going to say what?
Probability of A or B.
Now?
Hmm.
Now we're talking about independent. What you are doing, what you want to do, you have already done it here. So just proceed from this step.
Probability of A and B.
Good. Probability of A and B is equal to 0.07. We got it on top. Is that so? On 9.1.1.
Yes.
So now probability of A times probability of B is equal to what? We substitute 0.35
07.
times what? 0.2. You must show.
0.2.
Therefore, you're going to say what? Yes. Why? Because probability of A and B is equal to what? Probability of
Of
A multiplied by what? Probability of
B.
B. Guys, is it difficult?
No.
Can we proceed? Are you tired? Is there anyone who was still writing? Hello?
No.
Are you guys tired?
No.
Okay. There we go. Is it visible?
No.
Do you know where to use no?
Yes.
Apa notanga nazvo. Just answer that.
Kana ngobva chithu musi.
Really, you like playing?
Serious.
I said use English or you log out from the meeting.
Sorry.
How about now?
It's not visible.
And how about you others, guys? You can say also.
It's visible.
It's visible.
Already check on the group. The question is already there.
Which one?
Which one? Do you have another group?
Mm.
Yeah.
Oh, the last one.
The pushing.
Hmm?
We've got a red wire here. We have Loeli. I hope we can do solution. Is that so that we don't waste time?
Yes.
Are we fine?
Yes.
And this is one and the same thing.
Yes.
So we're going to have what?
Probability of A or B equals to probability of A plus probability of B minus probability of A and B.
Charunjez. Then we substitute, right?
Yes.
Orugawa mkwevo. Derichi. Petani.
Yes.
Oh, ndichinomerisa network yafara ri.
Yes, I'll go far. Network is
Ya runozviona zvigevenga.
far.
Uh,
You got that, is that so?
yes.
So they said the
Yes.
event, this is 9.1.2. This is 9.1.1. They say the two events independent. So you must first get probability of A multiplied by probability of B.
Probability of A multiplied by probability of B equals to 0,2 multiplied by 0,5, which is equals to 0,1. Therefore, events A and B are independent. Probability of A and B is equals to probability of A multiplied by probability of B.
Probability of A and B, we get that is equals to probability of A times probability of what? Of B.
Probability of
Is that so?
is.
Yes.
Any question?
No question.
We can't do the one and the same thing as if we are going crazy. We're ending here. Is that so?
Yes.
Those are the two
Yes.
questions. You will just do it for practice, you guys.
Baba.
Are we fine? Is there anyone who have got a question?
Yes.
Hello? Yes, you can ask.
Uh, there is this formula issues.
Are you talking
Probability of
about the
A
things?
or B is equal to probability of A plus probability of B. So I wanna know, Uri, where do we use this formula?
When the two events are mutually exclusive.
Or when the two events are. So we don't use it to prove. Hello.
Hello?
We don't use it to prove, right?
No, you can even use it.
Okay.
But normally,
Then
normally they prefer this one because you'll be given this and you'll be given that. So you must find that.
No, present.
Huh?
Yesterday.
Sorry? I didn't hear what you were saying. Anyways, guys, let's